which is like the most important topic in this chapter from NEET perspective. So Young performed this double slit experiment where you have two slits. Let's look at these two slits. This is slit number 1. This is slit number 2. Let's call this S1 and S2. So basically, lights from these two slits are coming from two different sources, S1 and S2. Fine. And what happens here? And this is the screen. And in fact, this is what you see on the screen. So what are you seeing? You are seeing alternate dark and bright bands. And that's the phenomenon of interference. Now, when we talk about the Young's double slit experiment, the first thing that we talk about is the path difference. And what do we mean by path difference? Now, the light from both of these sources, where do the light go? So the light waves, they actually reach the screen. Now, let us consider any point P on the screen. Let's randomly consider any point P on the screen. Now, the light wave from S1 will go till P like this. Similarly, the light wave from S2 will reach till P like this. So, basically, this is the path. The S1P is the path that is traveled by the wave, and S2P is the path that is traveled by the wave 2. So if you want to calculate the path difference between these two waves, what is the path difference? So if we draw a perpendicular, so I think needless to say that S2P is greater than S1P. So this path is longer. So if you want to find out the difference, just draw a perpendicular here like this. Now this distance is basically, so looking at this, you can see that S1P is actually equal to this distance from here, right? So this much is the extra distance. So this is nothing but the path difference. So this much distance is the path difference, which is generally denoted by delta x. And how do we calculate path difference? It is y divided by capital D into small d. So what is this capital D, small d? So capital D is basically the distance of the screen from the slits, and small d is the distance between the two slits. And what is y? Y is nothing but distance of the point P from the center. This is y. So let's say this is the center. So from the center of the pattern which is obtained on the screen, so from the center to how much, where is the point P placed? That is the distance y. So we can calculate path difference using this expression. Now again friends, I am not getting into the derivation of these expressions because that I have already discussed in wave optics video of class 12 physics. So please watch that video. Only after that you watch this video for a quick recap. Okay, so this is how we calculate path difference. Now the question is, how do we find out the position of the bright and the dark fringes on the screen, which we see the bright and dark bands on the screen. So the position of the bright fringes. So where will we get bright fringes? So bright fringes refers to the positions where the intensity is maximum. So wherever the intensity is maximum, we see bright fringes, right? So basically the position of the bright fringes is given by this expression, n lambda capital D divided by small d. Now you might ask, what is this n? So n can take values of integers. Basically n can take values like 0, plus minus 1, plus minus 2, plus minus 3 and so on. So now here you might again get confused that why is n taking these values? That's because these bright fringes are discrete. So if you look at the screen, so you see here you have a bright fringe. Again you have a bright fringe here. Again you have a bright fringe here. So you know there are discrete positions where you have the bright fringes. And what are those discrete positions? So those discrete positions will be determined by the value of n. When n is equal to 0, that would actually correspond to the central fringe. So if you put the value of n is equal to 0, then the value of y will be equal to 0, which means that the position of a bright fringe is at the center. Y is equal to 0 means exact center. So at the exact center, you have a bright fringe. Then when you put n is equal to plus 1, you will get y is equal to lambda capital D by small d. So that tells you the position of the next bright fringe here. And when you put n is equal to minus 1, that tells you the position of the bright fringe which is below the central fringe. So like let's say that this is the central bright fringe. So you will have one bright fringe on top of that, one bright fringe on below that. Similarly, you will have one bright fringe corresponding to n is equal to 2. Similarly, you will have one bright fringe corresponding to n is equal to minus 2. So in this fashion, you will have bright fringes at specific locations. Now similarly, you will also have dark fringes, and obviously dark fringes would correspond to those positions where the intensity is minimum. Right? Now the condition or the expression to find out the position of the dark fringes is n minus 1 by 2 lambda capital D by small d. So here the value of n starts from 1. Why is that? Because at the center you cannot have both bright and dark fringe, right? At the center you only have bright fringe. So if we put n is equal to 0 in this case, then the position of the dark fringe will be where? So the position of the dark fringe will be equal to minus 1 by 2 lambda capital D by small d. Right? So in this case, the value of n starts from plus minus 1, plus minus 2, plus minus 3 and so on. So when you put n is equal to plus minus 1, that corresponds to the bright fringe which is located on either side of the central bright fringe. And then for n is equal to plus minus 2, it is like the next dark fringe. Like here you have one dark fringe, then again you have a dark fringe here, again a dark fringe here. So as the value of n increases, the position of your dark fringe also keeps changing. Now the next thing we talk about is the fringe width. Now another interesting thing to note is that here we see on the screen that these bright and dark fringes, all of them have equal width. Width of all the fringes are the same. So how do we calculate fringe width? Fringe width is basically the distance between two consecutive bright fringes. Now let us say here in this case, this is a dark fringe, then this is a bright fringe, again this is a dark fringe, this is a bright fringe, dark fringe, bright fringe and so on. So this is dark, this is bright, again dark, again bright and so on. So if you want to calculate the fringe width, so this is actually the distance between two consecutive bright fringes or two consecutive dark fringes. Like this much is the fringe width. That means the position of this dark fringe till this dark fringe. Right? So that would give you the position, that would give you the width of a fringe. Or you can say the distance between two consecutive dark fringes or two consecutive bright fringes. So if you actually calculate that, you see that fringe width comes out to be fringe width, which is denoted by beta, is equal to lambda capital D by small d. So how can you calculate fringe width? So like you find out the position of the first bright fringe and then the next bright fringe, like bright fringe corresponding to n is equal to 0, then bright fringe corresponding to n is equal to 1, and then you subtract the 2. So you get the fringe width. So now we talk about the intensity of the fringes. Now if you talk about the intensity of these fringes, so you can actually draw a graph like this. Now if we actually talk about the intensity of these fringes, it's pretty simple, because what we see that we have alternate dark and bright bands. So we can draw it in this fashion. Let's say that these are the alternate dark and bright bands. This is dark, then you have bright, then again dark, bright, again dark, bright, again dark, bright. So this is how you have the fringes, right? So basically, whenever you have a bright fringe, the intensity is maximum. Whenever you have a dark fringe, the intensity is minimum. Again, bright fringe maximum, dark fringe minimum, bright maximum, dark minimum, and so on. So basically this is how the intensity is changing. So at one point, like for the bright fringes it's maximum, for the dark fringes it is minimum. So basically if you want to calculate the intensity of fringes at any point on the screen, so the intensity at any point will be equal to the sum of the intensities of the two waves. Right? Now let us say, not exactly sum basically, but just now we saw like when two waves superimpose, they form the resultant wave whose intensity is I, which is given by I1 plus I2 plus root 2 root over I1 I2 into cos phi. So this is how we will calculate the intensity in this case as well. Right? Now let us assume that if I1 is equal to I2 is equal to I0. That means we are assuming that the intensities of both the waves which are superimposing, both the waves 1 and 2, they have same intensity, which is I0. So in that case, we say that the intensity of the fringes is given by I is equal to I0 cos square phi by 2. So this is like a generalized expression which in a way has been derived from this basic expression. Now, how do we relate this expression with what we have learned in the previous slide, that at maximum intensity it is this, at minimum intensity it is this. So how do we calculate maximum and minimum intensity from this? Now when we talk about so this is a general expression which is true for both bright and dark fringes. Now when we specifically talk about the intensity of bright fringes, in that case the value of intensity is maximum, right? So in maximum intensity would be how much? So the value of intensity would be maximum when cos square phi by 2 is equal to 1. Right? So when cos square, okay, one more thing here, I think I have missed 4. Right? So this would be I is equal to 4 I0 cos square phi by 2. Right? Now when we are looking for the maximum value of I, so I will have maximum value when cos square phi by 2 is equal to 1. That means the value of maximum intensity would be 4 I0. So you can say that the intensity of the bright fringes will be equal to 4 I0. And what about the dark fringes? The dark fringes will have minimum intensity. Minimum intensity will be how much? When the value of cos square phi by 2 is less. Now in this case, cos square phi by 2 cannot be minus 1, because even if cos phi by 2 is minus 1, cos square phi by 2, when you square minus 1, it becomes plus 1. So that means the minimum value that cos square phi by 2 can have is 0. So the minimum intensity will also be 0. So basically when you look at the intensities, then the dark bands will have 0 intensity and the bright bands will have intensity equal to 4 I0. So from this, you can also derive an expression, or you can write an expression where you can say that intensity of the fringes I is equal to I max cos square phi by 2. So I'm just putting, instead of 4 I0, I am putting I max. So this is an expression of intensity of any of these fringes in terms of the maximum intensity. Right? So basically this would be the intensity at any point, because when we talk about the bright and the dark bands, we are just talking about the intensities at these 2 points. But there are many points in between them as well, right? So if we want to find out intensity of any of these points, then we need a general expression which will help us to find out intensity at any point. So that expression is this one, right? Okay, so in this fashion, we can find out the intensity. So Young's double slit experiment talks about path difference, phase difference, bright fringes position, dark fringes position, fringe width, and intensity of fringes. Now, the next thing that we will discuss is what happens if we introduce a slab in the path of one of the waves. Like if you look at this picture, it becomes more clear. Like till now, it was like you have 2 slits, S1 and S2, and then the waves coming out from these 2 sources, they reach the screen and you see the interference pattern. Now, what if we introduce this slab? As you see here, this is a transparent slab which has been introduced in the path of one of these waves. So in this case, we find that the entire fringe pattern which was seen on the screen, that gets shifted. So what do we mean by it gets shifted? Now let us say that this slab which has been introduced, it has a thickness T. And let's say that this transparent slab has a refractive index mu and it has a thickness T. Okay. So what happens is I'll first explain what do I mean by fringe shift. Let's say that initially this is how the fringes were. Okay. Let's say this is a dark fringe, bright fringe, again dark, again bright, again bright, and then again you have dark. So let's say before you introduced the transparent slab, this is how the fringes were. Now once you have introduced the slab, then also you still see transparent, you still see alternate dark and bright bands. So that is still there. But how is it different? The only difference is that, let's say that this dark fringe was here. So now this dark fringe would have shifted somewhere here. Similarly, this dark fringe has shifted somewhere here. So there is an overall shift in the fringe. So even though the fringe pattern is still the same, but the entire fringe thing has shifted by some distance. And how much is that fringe shift? That is given by this expression. So the fringe shift is equal to mu minus 1 into t, capital D by small d. And what is this? From where do we get this? So basically this mu minus 1 into t is nothing but the path difference. Because the moment we introduce this slab in the path of one of the waves, then the path difference gets altered. So now the path difference is mu minus 1 into t. Now this multiplied by capital D divided by small d gives you the fringe shift. So this is how we calculate fringe shift. Okay, now if I ask you that how many fringes got shifted, how many fringes in the sense that, let's say that this fringe was here. So it got shifted by 2 fringes, or it got shifted by 4 fringes or 6 fringes. So how do we know how many fringes got shifted? So that's pretty simple. Fringe shift divided by fringe width. So how do we get this formula? That's because fringe width basically corresponds. So when we talk about the fringe width, so fringe width corresponds to how many fringe? So fringe width talks about one fringe, right? So fringe width corresponds to one fringe. So when we talk about fringe shift, so by unitary method, fringe shift would correspond to 1 by fringe width multiplied by fringe shift. And that's exactly what we are doing. So basically this would be the number of fringes. So number of fringes shifted is equal to fringe shift divided by fringe width. So fringe shift is given by mu minus 1 into t, capital D by small d. This entire thing divided by fringe width. And just now we saw that fringe width is capital lambda capital D by small d. So all these will get cancelled. So the number of fringes that got shifted will be equal to mu minus 1 into t divided by lambda. So in this fashion, we can find out the number of fringes